Hello, smart mathematicians. Let's look at the proof of the angle at the center theorem. Okay, right. So what does this theorem say? The angle subtended by an arc at the center of a circle is double the size of the angle subtended by the same arc at the circumference. The angle subtended by an arc at the center of a circle is double or two times the size of the angle subtended by the same arc at the circumference. That's what the theorem says. This is the arc AB, right? It subtends which angle at the center? It subtends angle AOB at the center. So this angle AOB is two times the angle subtended by the same arc AB, where? At the circumference. And we're talking about which angle here? Angle ACB. You see that? So it means angle AOB is two times angle ACB. And we want to prove that. Okay? And then now we have to remember the reason that we write. We say angle at center equals two times angle at circumference. Okay, right, let's move on to the proof part. But before we look at the proof, I want us just to discuss a few concepts that we're going to use when we're proving this theorem. Right, remember the exterior angle of a triangle. Right, let's name these angles. Let's say this is angle C1 and angle C2, angle A1 and angle A2, angle B1 and angle B2. Right, so let's look at angle, maybe let's start with angle A2. It's an exterior angle. Okay, you see that? So if we say angle A2 is equal to what? The sum of what? The angle of B1 plus C1. Okay, the sum of the opposite interior angles. Remember that. Okay, I'm not going to write anything, just discussing here. And then the other concept that I want us to remember is that the angles opposite equal sides are equal. Angles opposite equal sides are equal. So if AB is equal to AC, therefore angle B is equal to angle C. So these are the concepts we're going to use when we are proving this theorem. Right. So what construction do we do? We want to prove that angle AOB is two times angle ACB. So construction, remember every proof there is construction and you have to do that construction. If you don't do it, then you're not going to get marks. You have to do the construction. Construct a line from C passing O. Construction, this is just a line from C passing O. Okay, then you construct a line like that. And then let's start with triangle ACO. In triangle ACO, let me just highlight the triangle. This is triangle ACO. Okay, right. So what you see here, we see that O1 is the exterior angle. So it means O1 is equal to C1 plus A. O1 is equal to C1 plus angle C1 plus angle A. So let's write that. Angle O1 is equal to angle C1 plus angle A. Okay, right. What's the reason? Exterior angle of triangle. Right, okay, see that. But now we know that CO or OC is equal to OA, right, since they are radii. So this side is equal to this side since they are radii. So therefore, angle C1 is equal to angle A, right? These are what? angles opposite equal sides. Right. So now it means that we can, where there's A, we can even put C1 here because they are equal. Angle C1 is equal to angle A. So we can say therefore angle O1 is equal to angle C1 plus angle C1. Okay, I have replaced A with angle C1 there. So angle O1 is equal to 2 times angle C1. Okay, and then you write that there. Okay, see that? Right, we've done the first triangle. We have to go to the next one. Okay, let's look at triangle BCO. Triangle BCO. So we're going to do the same thing basically. So in triangle BCO, so what can you say? So angle O2, angle O2 is equal to angle C2 plus angle B, right? Exterior angle of triangle, right? And then, but angle side OC and side OP are equal. OC is equal to OP, the radii. Right, so meaning that therefore angle C2 is equal to angle B, right? Since the angles opposite equal sides, they are opposite, angle is opposite equal sides. So now it means here we can replace this angle B with C2 because since angle C2 is equal to angle B, so it means angle O2 is equal to angle C2 plus angle C2, right? And then O2 is equal to 2 times angle C2. Okay, right, so we can write that there. Right, okay, so we've managed to get this now. So if you check here, this is 2 times angle C1 plus 2 times angle C2, and then here is angle C1 plus angle C2. This whole angle here is angle C1 plus angle C2, and then this angle here is angle 2 times angle C1 plus 2 times angle C2. Do you see that? Okay, so let's just use that to prove our theorem. So we said that angle AOB, this whole angle AOB is equal to 2 times angle C1 plus 2 times angle C2. Okay, right. But remember that angle AC angle ACB is equal to angle C1 plus angle C2. See that? Okay. If you check here, we can factor out 2 here. It's a common factor. AOB is equal to 2. Then we factor out 2 there. We get angle C1 plus angle C2 inside the bracket. And then if you check, this is angle C1 plus angle C2 is actually angle ACB. You see that? So we can say therefore angle AOB is equal to 2 times angle ACB. We've proved the theorem. Done. Okay, so that's what it's supposed to do then. Right, remember that we say that the angle subtended by an arc at the center of a circle is double the size of the angle subtended by the same arc at the circumference. And then the reason we write, we say angle at center equals 2 times angle at circumference. Thank you very much. We're going to meet in our next lesson.